Hi Long, this is FRQ number 3. So part A asks for the graphs for angular momentum, torque, and kinetic energy. Angular momentum is in kilograms meters squared over a second. Torque is in newtons times meters. And kinetic energy is in joules. And they're all over time, which is in seconds. So angular momentum is I omega. Omega is increasing constantly, so this would also, so the graph would be like this. Torque is I alpha. And alpha is constant, which means that the graph for torque would be like this. And then after 5 seconds, it stops accelerating, so that means it's off to 0. And then kinetic energy is 1/2 mv squared, 1/2 I omega squared. So this means that the graph would be like this. And then it'll stay like that because omega doesn't change. So part B asks for the graph of the hanging mass. So first, they're all over seconds. This way. And the last one is over velocity, which is meters over seconds. Kinetic energy is in joules again. Potential energy is also in joules. And then momentum is in kilograms meters per second. So the graph for momentum would be like this. And then after 5 seconds, the string will disconnect, and I take that as it is no longer connected here and it's still falling down, which means I'll accelerate faster. So for 7 seconds, it will be like this. The graph for potential energy will be like this. The graph for kinetic energy, the velocity is increasing constantly until 5 seconds. And then after 5 seconds, it will increase a bit more. The velocity increases faster. And then it'll be the same thing for kinetic energy over velocity. Part C asks for angular velocity at t equals 5. So at 5 seconds, it's at 10 spokes per second. And then there's 16 spokes in one revolution. And 1 rev is 2 pi rads. And when you multiply this, you get about 3.93 rads per second. and this would be going counterclockwise. Part D is asking for acceleration. So the wheel is accelerating at 2 spokes per second squared. And then you multiply by the same thing, so 16 spokes is 1 rev, and 2 pi rads is 1 rev, so you get this, and this would be equal to about 0.785 rad per second squared. And then R alpha is equal to A. R is given to be 30 centimeters, or 0.3 meters, times 0.785. And when we multiply this, A is equal to about 0.236 meters per second squared. Okay. Part E is asking for the tension. So on the block, mg minus t is equal to ma. So t is equal to mg minus ma. M is given to be 50 grams, which is 0.05 kilograms. Gravity is 9.8. And then acceleration is 0.236. And t is equal to 0.478 newtons. Part F is asking for net torque. So torque is equal to F perpendicular R. The S perpendicular is the T, so it's TR, so torque is equal to 0.478 times 0.3 meters. So torque is equal to about 0.144 newtons times meters, and it's acting counterclockwise. Part G is asking for the inertia. So you set net torque equals to each other. So I alpha, I cis alpha is equal to 0.144. Alpha is 0.785 over there. So you divide it. So the inertia of the system is equal to 0.183 kilograms meter squared. Part H is asking for the mass of each spoke. So the inertia of the system is equal to m r squared plus 16 for 16 spokes. 1/3 is the center of mass at the end, the c value at the end. M over 48 is the mass of each of them, r squared. So 0.183 is equal to m 0.3 squared plus this. You multiply it, so this would be 0.09 m plus this is about 0.01 m. So 0.1 m is equal to 0.183. M is equal to 1.83 kilograms. Now the mass of each spoke is equal to m over 48. And this is 1.83 over 48 is equal to 0.038 kilograms. And then you multiply this by 1,000 per gram, so it would be 38 grams. Part I asked for kinetic energy of the system. So this is equal to Ke rot rotational plus Ke linear so this is equal to 1/2 mv squared plus 1/2 I omega squared plus 1/2 mv squared. So it's the same thing as 1/2 I omega squared plus 1/2 m r squared omega squared. Oh, the omega at 3 seconds is 6 spokes per second times this. And this is equal to about 2.36 rads per second. So K system is equal to 1/2 I is 0.183. Omega is 2.36. Mass is 0.05. R is 0.3. And omega is that. And you multiply together and add them, it equals to about 0.52 joules. Okay. Part J asks for the hanging mass on the right. So everything is the same except for this is added and this is changed. So set net torque equal to net torque. So torque is equal to minus the other F perpendicular R minus that one. So torque is equal to T1R minus T2R. T1 is mg minus is MA. T1 is equal to MG minus MA. T2 minus M2G equals M2A. So T2 equals M2G plus M2A. So the torque is equal to R times mg minus ma minus m2g minus m2a. The net torque is 0.144. R is 0.3. M is 0.07. A is the same as 0.236. Minus 9.8 m2 minus 0.236 m2. So 0.144 is equal to 0.686 minus 0.0165 minus 10.24 m2. You isolate for one side, so subtract and add negative 0.189 goes to negative 10.24 m2. Divide m2 is equal to 0.019 kg. This is equal to 19 grams. So part K is asking for tension in the left string. So tension in the left string is equal to 0.07 times 9.8 minus 0.07 times A. T nu is equal to 0.67 newtons. And the O tension is this. So the tension in the left string increases. Because the new tension is greater than O tension. Thank you. This is FRQ number 3.